Welcome to aminacademy.com. In engineering mechanics, regarding a simple pendulum, let us do some solving problem regarding gain or loss of number of oscillations. Look at this example. Gravity at the pole exceeds the gravity at the equator in the ratio 350 is to 351. If a pendulum regulated at the poles is taken to the equator, find how many seconds a day will it lose. That means position of the pendulum changes from one place to another, then ratio of the gravity is given, then we can find how many seconds a day will it lose. Here the given things: gravity at pole, gravity at pole, that is, we can write this as Gp is 351, and gravity at equator gravity at equator Ge equal 350. Now change in gravity when the pendulum is taken from pole to equator. Change in gravity is, that is, pole to equator is, change in gravity is dg, which is equal 350 minus 351, which is equal -1 dg. Now let dn, number of seconds the pendulum, number of seconds the pendulum will lose in one day, will lose in one day. Due to change the position of the pendulum we kept, then seconds will lose. We have to find that how much the seconds, how much length should adjusted for the change in number of seconds. We know that number of seconds in one day equal that is n equal 24 hours, 60 minutes, 60 seconds, which is equal 86,400 seconds for one day. Now we know that dn by n, for simple pendulum we know that dn by n is equal dg by by 2g. Then dn over 86,400 equal dg is -1 over 2 into 301. 30, not 301, 351. Therefore, from that, you'll get dn equal minus 1 into 86 400 over 2 into 351, which is equal, after calculation, it gives minus 123 minus 123.07 seconds. That means here the minus signs indicates the pendulum will lose. Therefore, we can write the pendulum will lose 123 seconds per day. Next problem. Find a length of a pendulum which will have 1 beat per second if such a pendulum loses 2.5 seconds a day. By how much the length must be shortened to keep the correct time. That means the pendulum will lose 2.5 seconds per day. If it is like that, then we have to shorten the length of the pendulum for some extent. We have to find that shortening length. Let time t, that is time period, t equal 1 seconds. Number of seconds the pendulum loses in 1 day, the pendulum loses in 1 day is given 2.5 seconds. Therefore, you can find the length of pendulum which will have 1 beat per second. Now, length of pendulum, which will have 1 beat per second is given, that is length is 1, now length is L, time is 1, that is 1 second, 1 equal pi into root L by G. Squaring both sides, we will get 1 square is 1 equal pi square into L by square root of line is G is 9.8. From that, we will get this one by cross multiplying, you will get L equal 9.8 over pi square by calculation, which gives 993 mm. 0.993 meter, which is equal 993 millimeter. That means, therefore, the length by which the pendulum should by shortened, we'll get dl equal length in mm by which the pendulum should be shortened to keep the correct time. Length should be shortened to correct the time. We know that number of seconds in one day per day equal 24 into 60 minutes, 60 hours equal 86 400 seconds. We know that the relation dn by n equal minus dl by 12, that is minus 2.5, means losing beats per day is 2.5 seconds over n equal dl over 12, which is further equal minus 2.5 86 400 equal minus dl by 2 into 993. Therefore, dl equal minus 2.5 into 2 into 993 over 86 400. So, which gives the calculation 0.0556 mm. That means the length of pendulum must be the length of pendulum must be shortened 0.0556 mm, then from the correct length, then we can get correct time. If you shortened the length of the pendulum by 0.0556 mm, the pendulum will oscillate in correct time. We have done. Please subscribe our YouTube channel.